Now let's look through the solutions of the homework that you had yesterday when you were given graphs of quadratics and you had to answer some questions on them. So the first thing here in question 8, we're shown three graphs, F, G and H, and we're asked to write down the coordinates PQ of the minimum points of each of these. So we can see on F, the minimum point is -1, 5. For G, it's 2, -1. Sorry, -1, -5. 2, -1. And for H, it is 4, 1. So I could just write my answers on the graph like that, but we really should write it down nice and clearly here. For F, sorry, part 1, the minimum for f of x is -1, -5. For g of x, it's 2, -1. And for h of x, it is 4, 1. Then they asked us to write each equation in this form, so in completed square format. And you'll notice there's no number outside the bracket, so we can assume that the coefficient of x squared is 1, and we can verify it if we need to, but because they've already told us that the format needs to be like this, it makes it really easy. So for part 2, we can write f of x as x, and we change the first one, x plus 1 squared minus 5. G of x can be written as x minus 2 squared minus 1, and h of x can be written as x minus 4 all squared plus 1. So there's my completed square format. And finally, they asked us to write it in the normal quadratic format. So we just have to multiply out our brackets. So for f of x, we're going to have x squared plus 2x plus 1 minus 5, which we'll write as x squared plus 2x minus 4. For g of x, I didn't give enough room here. For g of x, we'll have x squared minus 4x plus 4 minus 1, which we can write as x squared minus 4x plus 3. And for h of x, we've got x squared minus 8x plus 16 plus 1, which can be written as x squared minus x minus 8x plus 17. So those are my three functions there. Then the third thing they asked us to do was to pick a suitable point on each graph other than the minimum point in order to verify each equation. What do they mean by that? Well, they mean pick a point and show that when you use the x value of that point, you get the appropriate y value. So for f of x, let's pick one. We want one that goes through. For example, this point here, -2, -4, is on my graph. So let me just use this actually. So for part 3, f of x, we've got the point -2, -4, and we know that f of x is x squared minus 4x plus 3. It doesn't matter which one I use there. So what I'm saying here is that when x is equal to -2, y should be equal to -4. So there's my formula for f of x, y equals x squared minus 4x plus 3. So if I plug in these, my equation should balance. -4 instead of y, -2 instead of x, and can I verify that that point is on the quadratic? Is -4 equal to 4 plus... I used the wrong formula. Sorry guys. Plus 2x minus 4. X squared plus 2x minus 4 is my formula for f of x. I was using the formula for g of x. So when x is equal to -2, minus 2x squared plus 2 by minus 2 minus 4, do I get minus 4 as my output? So let's see. 4 take 4 take 4 equal to minus 4. Yes, those guys cancel. We get minus 4 equals minus 4, and that is verified. Let's do the same thing for g of x. So g of x, we've got y equals x squared minus 4x plus 3, the one that I first wrote down. And let's look at the graph. And it doesn't matter what point we pick. I'm going to pick a nice and easy one here. This is the point 1, 0. So I'm saying that the point 1, 0 is on the graph of g of x. So if I fill in x equal to 1, I should get y equals 0. And let's find out if I do. 1 squared minus 4 by 1 plus 3 equal to 0. 1 take 4 plus 3. Yes, that's equal to 0. So that one's verified. And finally, h of x, I've got y equals x squared minus 8x plus 17. And I'm looking for a point on that graph other than the minimum point. Here's one, 3, 2. So 3, 2 is on my graph. 3, 2 is on h of x. So if x is equal to 3, y should be equal to 2. And let's find out. 3 squared minus 8 by 3 plus 17. Does that give me 2? 9 minus 24 plus 17 equal to 2. Well, that is 9 minus 7. Yeah, that's 2. And that's verified. So that's what they were asking us to do in part 3 of that question there. So if you weren't sure what you were being asked, the important thing is, do you now understand what they were asking you to do? As always, let me know if there's a part that you don't understand. Let's look at question 11 then. So question 11, we'd actually worked with some of these. You were sketching. We sketched these two last night. And so hopefully you'll have noticed that B, this was B, and this was C, and this was A. And one of the ways of identifying them, other than just sketching them, would be, of course, to find the roots. So this was the only one with real roots, real distinct roots. This one had equal roots. And this one had no real roots. So, of course, it never intersected the x-axis. Then they asked us to write each equation in completed square format. So let's do them one by one. This one's the easiest. Let's do B first because B is already a completed square. For A, then, we've got x plus h all squared plus k, which multiplies out to give us x squared plus 2hx plus h squared plus k equal to x squared minus 6x plus 10. So I'm doing this one down here. And my x squareds are the same. My x term gives me that 2h is equal to minus 6 and h is equal to minus 3. And my constant term gives me that h squared plus k is equal to 10. So h squared is 9 plus k is equal to 10 and k is equal to 1, which means that A can be written as x minus 3 squared plus 1. So A can be written like that. We'll do the same thing with C. Of course, when I multiply out my brackets, I'm going to get the same thing. X squared plus 2hx plus h squared plus k equal to x squared minus 6x plus 8. So again, the x squareds are equal, so I'm just looking at the x term. 2h is minus 6, so h is minus 3. And my constant, h squared plus k is equal to 8, so 9 plus k is equal to 8, and k is equal to minus 1. So then C can be written as x minus 3 all squared minus 1. There's B already done, because that was already a perfect square. Okay, so Hopefully you're feeling okay about the graphs of quadratic equations and their minimum points and completed square format.